This is a Joule thief, and at face value it may look like just an average flashlight. However, when it is turned over, one can see a depleted AA battery. Now this doesn't quite make sense, as a bright white LED usually requires more than 2.8 volts to function, and a depleted AA battery only provides less than 1. Now this works because of Faraday's law of induction and Lenz's law working in conjunction. Faraday's law of induction says that current is produced whenever a magnetic flux changes, and Lenz's law states that the current that is produced moves in a direction opposite to the flux that created it. To get a better look, it's important to look at the schematic. Now, in the schematic, there are several ways the current can flow. Firstly, it can flow through one inductor, which then flows into 1 kiloohm fixed resistor, and then finally into the base pin, allowing energy to pass through the transistor. Additionally, the current can flow through one inductor, and then it can flow to an LED. However, the LED does not have enough voltage to turn on, so the circuit is not closed. However, the circuit still can be closed because current can run through the collector and is allowed to pass through the transistor because of the current provided at the base pin. Now it's important to take a look at the inductors. The inductors found in the prototype, or more specifically the inductor, simply 2 copper wires wrapped around a ferrite core to create 2 magnetic fields, like the magnetic fields found in the inductors in the circuit diagram. Now, these are the inductors found in the circuit diagram, and as current flows through the circuit, both inductors gain some energy in their fluxes, and due to Lenz's and Faraday's law, this increased flux energy must induce a current, which transfers to the opposite side of the flux flow, which happens to be the other inductor. Now, this increases the energy found at the base pin, allowing more current to flow through the circuit and increasing this cycle of energy found in the fluxes. However, at some point, both fluxes become saturated and no more energy can flow. Now, this slowly depletes one of the inductors, and because of this, there is less current found at the base pin, meaning less current flows through the circuit, fully depleting one of the inductors. However, one of the inductors still has all of its energy which must be transferred somewhere, so it's forced to its only remaining option, which is the LED, which now has enough voltage to function. And this happens several thousand times per second. So as one can see in this prototype diagram, it appears to be completely continuous.